So, good afternoon, everyone. Welcome to this NITheCS Colloquium. This afternoon, we chose another format. We chose the format of a panel discussion because we want to start celebrating the International Year of Basic Sciences for Sustainable Development, which is a UNESCO supported initiative. And officially it starts this coming Friday. So on Friday, if you go on the official website of UNESCO for this International Year, you can register for the initial opening of the International Year of Basic Sciences for Sustainable Development. And there is a fantastic program with very high caliber speakers. Yeah? And we want, as NITheCS, we want to replicate the opening, and we've invited some of our associates to discuss a little bit, to introduce, to create some initial momentum for this international year. Yeah. So before we, the first thing that we should do, I should introduce you to the various panelists, and I will ask them then in the order in which they appear on my screen to introduce themselves. Yeah. So with us this evening we have Dr. Mark Nasila. Yeah, Mark, would you like to introduce yourself briefly, and then we will go on to the other ones.
Yeah, thank you so much, Francesco, for the introduction, and to all joining us, the panelists. My name's Mark Nasila. I'm the Chief Data and Analytics Officer for the FirstRand Risk Function. As you're all aware, FirstRand is a financial institution that runs various financial services, from FNB, which is the retail bank, RMB, which is a corporate bank, as well as offerings through West Bank, the Connect MVNO, and other holdings. And my main role in the organization is to making sure capabilities such as data analytics, AI, machine learning are helping us manage risks proactively, effectively, efficiently, including modernizing the risk function through digitization. Thank you so much.
Thank you, Mark. Thank you very much. So with us as well is Professor Zurab Janelidze from Stellenbosch University. Zurab, would you like to introduce yourself briefly?
Thank you very much. Indeed, I'm at Stellenbosch University. I also serve as the president of the South African Mathematical Society. I am a mathematician. My research area is in mainly in category theory, but the nature of the subject is that it touches on various different fields. I'm interested in all aspects of mathematics, as well as its links with other fields of science, and that's where I will stop.
Thank you, Zura. So the next panelist is Dr. Happy Sithole. Happy, please, would you like to introduce yourself?
Thank you very much, Francesco, and good afternoon, everyone who's joining us today. My name is Happy Sithole, and I am currently the Center Manager for the National Integrated Cyber Infrastructure. In short, this is NICIS or NICIS. NICIS is looking after the provision of broadband, high performance computing, and big data analytics. So that's in short what it does. I don't want to bore you a lot about NICIS. I can just tell you a little bit about myself. My background, I am from material science, physics background, and you can wonder why I got into all these other areas in their linkages. This will be some of the things to discuss, but I am very happy to be here and also to celebrate the International Year of Basic Sciences. Thank you, Francesco.
Thank you very much, Happy. And with us this evening is also Dr. Anwar Vahed. Please, Anwar, if you would like to introduce yourself.
Thank you, Francesco, and good afternoon, everyone. Yeah, my name is Anwar Vahed. I'm responsible for what is called the data-intensive research initiative for South Africa, or TIRISA for short. And this area forms part of NICIS, as Happy indicated, and we're part of NICIS. And we're responsible for research data management and data intensive research services for the research community of South Africa. My background is computer science, AI or machine learning to be exact, but mostly nowadays I'm involved in data management. So thank you, Francesco.
Thank you, Anwar. And sorry, I think in all of this, I didn't introduce myself. My name is Francesco Petruccione. I'm the interim director of NITheCS, and I'm also a professor of quantum computing at Stellenbosch University, and I still have a fractional appointment at my old university, the University of KwaZulu-Natal. Yeah. So one suggestion that was made by one of the panelists was to encourage the participants to introduce themselves in the chat so that we can gain a little bit of a picture of who is in the audience and adapt the discussion accordingly. Yeah. Before we start, I just wanted to briefly remind everyone what this International Year of Basic Sciences is about and why UNESCO decided to declare 2022 this special year. Yeah? If you go on the website that you can Google in 3 seconds of the International Year, you will see that there are a few topics and a few themes for this International Year. Yeah? And I just wrote them down in front of me because otherwise I'd forget them. And the 4 main topics of the International Year of Basic Sciences are, one is enhancing the inclusive participation in these disciplines, yeah, which is a big issue for, as we all know. Yeah. The second topic is strengthening education and training. Yeah. The third topic is how do you finance all of this? Yeah. And the fourth topic, which I think is really, really interesting, is how can we generalize the open science approach to basic sciences, yeah, and how to can make use of that. Yeah, there are also a few more specific themes, yeah, dedicated to that should be discussed and promoted during this year. Yeah, one is the presence of women in basic sciences. Yeah, another theme is basic sciences as a source of international dialogue and peace. Yeah? And this is also something very, very, very critical. Another theme is science as a global public good. Yeah? Innovation, yeah, for economic development. Yeah, that's of course something that is close to all our heart. The next theme is education and human development, yeah, which is of course closely related to the topic of education and training. And of course, finally, we all want to do basic sciences to meet global challenges, yeah, like the Sustainable Development Goals. Yeah? So these are the themes and topics officially declared by UNESCO to celebrate this International Year. Yeah? And I think just to start, yeah, and without wanting to impose any discussion on the panelists, yeah, I would like maybe to ask each panelist to make a first brief statement on how they see themselves and the discipline that they represent placed in this year of celebrations. Yeah. And again, I still follow the order which changed from the beginning, in which people appear on my screen. Yeah. So let's start with Zura. Zura, please. What are your first comments on this? And
so I wanted to start with showing everyone something on the internet, and I'm still looking for the thing. I kind of lost it between my hands. So if it is okay that I take, maybe I'm on the taking second place, is that fine to prepare?
Yeah, please. Okay. Then I would ask Happy to be the first one to make a statement while Zurab finds his bearings in what he wanted to share. Yeah, happy, please.
Thank you very much, Francesco, to let me start off with this. I would say, for me, when we look at the importance of the basic sciences and for this year to be declared an international year for basic sciences, it's very, very important. And as scientists, we would recall that at some point, we had a situation where we were sitting and thinking, maybe the basic sciences are under attack and they might diminish. And at some point, all the type of basic sciences felt the same way. And I would say we went in that era where we were looking at the situation where a lot was talked about innovation. And when we talked about innovation, more and more was not accommodating what basic sciences can come into. And there was that sort of a view that basic sciences have got no place in terms of research, development, and innovation. And we would recall at some stages where we were talking about funding of research, that even funding of research was looking only at applied sciences. So I would say it is very important if you look at those vulnerabilities where they come. I would like to also zoom in into the organization that I belong to, which is the Council for Scientific and Industrial Research. And we have seen evolution in this organization where you have got the Council for Scientific and Industrial Research. Always there has been this sort of flip-flop between maybe we invest a lot on the scientific background and we lag in innovation. And at some point when a new strategy is formed, it says, let's push on this I, which is the industrial part. Let's reduce on the scientific. So you can see this tussle between innovation and the basic sciences. So I think it is really important for UNESCO to have declared this year the year for basic sciences, because it is important for us to look into all the innovations that take place. What is the contribution of the basic sciences? And we should not only think that the development of the basic sciences as they will sustain us for the future, because there are still quite a number of things that can be still unraveled on the basic sciences that needs to be there. And I think if you look at the themes that come here, we will never be able to unravel all those basic aspects in all fields of the sciences that will propel innovation if we don't bring everybody on board. Hence, I'm quite pleased to see the visibility of women, making sure that we bring in and we engage this dialogue between the science and public good, because we need to be able to see how the science contributes to the public good and innovation and economic development. I think those are given. Of course, we need to develop people and in meeting global challenges. If we look at the complexity of the challenges that we face today, we just come now from the COVID-19 pandemic, and we can surely be able to see it started with basic sciences, how to understand how COVID spreads. It went back to say, understand the movement of a drop. And that went back to the sciences. So we need to go back to the basics when we face the challenges. I think that climate change today, it also shows us, if we don't understand the laws of physics, how we understand the movement of the temperatures, how do we understand the movement of heat from the basic elements, we will never be able to understand this. And I think many other challenges of development my colleagues will share. But I think those are very important issues for us to focus on. Thank you very much, Francesco.
Thank you, Happy. That was a fantastic first introduction to the discussion. Zurab, are you ready now?
I am ready, yes. Thank you very much, Francesco. So since I'm a mathematician, I want to focus on mathematics. And as you said, we should kind of talk from the angle that we represent. And what I would like to do is to surround what I wanted to share in this 5 minutes around a certain Wikipedia article, which I'm going to share now with everyone. So I'm sharing my screen, and I hope that everyone can see it. So this is Ada Lovelace. She was a daughter of English poet Lord Byron. She was a mathematician. In fact, her mother also was a mathematician, Lady Byron. And she worked together with Charles Babbage on something that Charles Babbage called analytical engine. Charles Babbage is a mathematician, a polymath, to be more precise, or maybe more general. So he's classified as a mathematician, philosopher, inventor, and a mechanical engineer. Analytical engine is basically a computer. This was the first decisive conceptual step towards inventing a computer. And for the work that Ada did on this idea of analytical engine, as it says here, she is often regarded as the first programmer. Now, why do I share this at this occasion? Because I want to make the following point, that one sometimes thinks that basic sciences, in particular mathematics, and maybe even more specifically pure mathematics, is not so immediately effective in solving real world problems we're experiencing right now. But this is true in a way, and the reason for that is because the universe is very complex and it has lots of layers. And pure mathematics studies the layer that is at the most fundamental level in a way, and it takes time to understand it so well that you can go to the other layers. And of course, the immediately next layer is applied mathematics, and then other sciences come there. And so developments in pure mathematics take time before they're visibly part of our everyday life. And there's a very good example here where these mathematicians, Charles and Ada, were working on something that they never saw brought to life. And now, today, we are using these computers that they conceptualize to read about them and to communicate to each other, being very far from each other. So in a similar way, one hopes that every century that mathematics brings is something that eventually, maybe after 100 years, as it is in the case of this, it's a bit more, will be used. But there is also another thing I wanted to say about mathematics, namely that sometimes, I mean, another misconception about mathematics is that it is very abstract and it is very, it's not very real. And I want to contest that because, in fact, for me, mathematics is a language which allows us to understand, or at least make sense of, how the world that we are able to perceive works. And when we try to kind of focus on the detail about a certain phenomenon, and then we go deeper and deeper and deeper into it, eventually we uncover that the constituents of the universe, and physicists know this better than anyone else, we don't know exactly what they are, but the best we can do with them is to describe them mathematically. And so as far as our consciousness has limitations, mathematics is the kind of the basis of how the universe works. So it's actually very much real, just like anything else we experience with our other senses apart from the thought. And an example I want to give here is time. We cannot see time directly. We cannot hear time directly. We cannot touch time. We cannot taste time, but we know it's real. One day there was a mathematician called Isaac Newton who decided to study time in a mathematical way. And he was studying time using the concrete things that kind of describe the structure of time, like the movement of objects and so on. And we know very well what his contributions are. The best we can say today about time is that it's a mathematical object which we perceive as the real line with so in very primitive language, a straight line with points representing numbers, right? And everything we know about time, or we do about time, for instance, in the context of physics, relies on this mathematical perception of time. The example here is that it's something that's real, but at the same time we can't see or taste or smell. And there are many other such parts of the universe which we cannot necessarily perceive using all of our senses, but it's only through thought that we are able to comprehend them. And in some sense, mathematics is the part of the universe where that can only be comprehended through thought. But then, of course, we can illustrate its presence using other senses as well. Yes, so the short message I wanted to make is that, for me at least, mathematics is the basis of how things work in general. And for me, a mathematician is someone who wants to understand how the world works at the most fundamental level possible. And then because it's so fundamental, it takes time before you really well understand it. And so applications can arrive very late, but also very soon as well. All the mathematics we developed before, we can find new applications for it, and applied mathematics is very effective in that. Thank you.
Yeah, thank you very much, Zurab, for the point of view of the mathematician. Thank you very much. That was very interesting. We will definitely come back to that just now. But let's first give, I still follow the order in which the panelists appear on my screen. Let's give Mark the opportunity to say a few words from his point of view.
Thank you so much, Francesco. And from my side, basically want to cover how do we scale the role of science. I think Happy mentioned a very important thing that in the past few years, we've seen that science has played a major role in not only dealing with challenges, but also making sure that some businesses, organizations, sectors reimagine themselves, solve problems, become more efficient. But we can't run away from the fact that science is also facing a lot of challenges. And one of the challenges is trust and ethics. And I think for science to realize its optimal value, it needs to be trusted even more by non-scientists. So as scientists, we need to make sure from a basic level, convince people in society that science is valuable, make sure it's ethical and the ethics is measured so that people do not doubt the role of science. If we do not convince everyone that science is ethical, then we're going to slow down. This requires an element of collaboration, and collaboration is key so that science also builds that trust on solving the right problems the right way in a representative way. The pandemic demonstrated that there's no sector that can solve problems by itself, even if you have all the resources. the value of science will come when there's collaboration and inclusivity to make sure that it carries along. There's even a bigger threat that if inclusivity and ethics is not solved, we're likely to see a new wave of inequality through science, because some organizations or countries will, get the benefit much faster and others will be held behind. And then lastly, we're also dealing with another pandemic of talent. And as scientists, we need to think of how do we create even newer ways or channels of learning, the science curriculum, but how do we also use our skills and talent optimally? Because as science becomes more and more common, we're going to find ourselves in a situation where talent is moving around, but also not being utilized promptly. And all these are building blocks of helping create maximum value of the science skill so that we can continue making Africa better. Thank you.
Thank you, Mark, for addressing a very, very interesting aspect of the discussion, and we will definitely come back to that just now. Anwar, please, over to you for an initial statement from your perspective.
Okay, thank you very much, Francesco. So the good thing about going last is that most of the important things have been said already. So I will just try to make some connections between what has been said by Zurab, Mark, and Happy. And I'll take an approach from, say, a strategic perspective or a helicopter perspective and ask the question, why is basic sciences, why is it important? And one way of looking at that answer is to look at what it is that we want to achieve as a country, as an institution, and as an individual. Now, from a strategic perspective, I'm sure many of us have heard about the government's position for South Africa to become more competitive, to become a more capable state, and all of that. And if you look at that aspect, if you have that perspective, then those impacts and outcomes, that's at the sharp end. And what we should ask is, what do we need as enablers? What do we need to have in place for South Africa to become more competitive, for us to be able to produce more valuable outputs, not just for us, but for globally. As was already said, most of the problems, the challenges that we face are global. And if you look at this, you can have different perspectives. You can look at it as a stack or layers, as Zurab has mentioned already, or something like an onion, and you ask, what is at the core of a country becoming more competitive, becoming more capable? Then the basic sciences is right in the middle, it's right at the core. And therefore, one must see basic sciences as a key enabler for South Africa to become more competitive and more capable. And in our area of data science, that is so important. The only way that we can really extract value from data, I'm now taking a position of that I'm occupying. The only way that you can actually get value from data is to apply the basic sciences. This is how we found solutions and ways in which we can manage COVID. And this is how we will find ways in which we will manage other challenges that Happy mentioned. Health is one, climate change is another one. Opportunities in bioinformatics, and in your area, Francesco, quantum, you know that the basic sciences is so fundamental to get any achievement in any of those areas. And we should, as a country, as different individuals and organizations, join hands and support the development of basic sciences throughout the pipeline. It starts at school, but we have to fill that entire pipeline from school to postdoctoral. And that is so my position on why this is so important, why the basic sciences are so fundamental and so key. So thank you for that, Francesco.
No, thank you. No, thank you, Anwar, for your comments. And since you mentioned me explicitly, let me also give my 2 bits and pieces. You know, on this panel, one of my hats would be that I'm also a theoretical physicist, yeah? And Zurab already addressed some of the issues about mathematics and theoretical physics and their quest for understanding what keeps the world together. Yeah? But there is another aspect that I would like to mention specifically, and Anwar mentioned quantum. Yeah? And this is a matter of of time scales, sometimes in fundamental basic sciences research. Yeah? You know, I'm a quantum physicist essentially, yeah, and quantum physics, the theory was formalized essentially 100 years ago. Yeah, it started probably in the 1900s, 1900. Yeah? But the theory as we use it still today was formalized roughly 100 years ago. Yeah. And not even starting to speak about more fancy modern aspects of quantum applications of quantum physics, like quantum computing, quantum cryptography, and so on and so forth. But just sticking to technologies that emerged from the first quantum revolution, yeah, of the fathers of quantum theory, Einstein, Schrödinger, Heisenberg, and so on and so forth, that developed, that understood basic phenomena like tunneling and things like that. Yeah. Those technologies led to some really relevant applications. Yeah? For instance, the semiconductor industry would not be possible without quantum mechanics. Yeah? Lasers would not be possible without quantum mechanics. Diodes would not be possible without quantum mechanics. And we all know in these times of load shedding how relevant LEDs are to see when we don't have power. Yeah? The point that I want to make is that it took more than 50 years from the development of the theory to this kind of applications. Yeah? And for instance, I think the semiconductor industry contributes roughly a quarter of the GDP of the United States, for instance. Yeah? So it's not an irrelevant aspect of the economy. It's really the core of the economy of many countries. Yeah? Unfortunately, in South Africa and in Africa, we missed out completely on the semiconductor revolution. Yeah, that other countries like Japan, Korea jumped on it. Yeah, and now that we are at the beginning of a second quantum revolution with quantum computing, quantum communication, sensing, and so on and so forth. Yeah, we should make an effort not to lose out on that. Yeah. And gratefully, our government supports now since a year or so a quantum technology initiative for the country, yeah? So that we will be able to catch up a little bit with what's happening in other parts of the world. Yeah? So the point that I want to make is that investing in basic sciences, training people, young people in basic sciences, yeah? Is an investment that sometimes brings fruits much later. Yeah? So it's a long-term investment. Yeah? Sometimes we can't expect to invest today and collect the fruits the next day. Yeah? Sometimes it takes a long time. Yeah? And you know, there are initiatives like the African Einstein initiative, I think promoted by AIMS. Yeah? That is one of those kind of investments, yeah? That where we can't expect the return to be immediate. Yeah? We need to be patient, but without that investment, we probably wouldn't go anywhere. Yeah? So it's really very crucial to support basic sciences. Yeah? And if I can wear now a second my NITheCS hat, yeah. NITheCS essentially is here to support basic sciences, yeah, because we support mathematics, theoretical physics, data science, statistics, the quantitative and computational aspects of biology, finance, astrophysics, climate change modeling, and Earth system modeling. Yeah? So NITheCS is essentially now the South African institution in support of basic sciences. Yeah? In a multidisciplinary, transdisciplinary way. Yeah? And I would even go even further and say that it should become an undisciplinary institute, yeah? Where the main objective is to solve the grand challenges. Yeah? Regardless from what silos of discipline people come from, people should work together and address those challenges. Yeah? But to go back to our discussion, everybody addressed one or different or several aspects of the themes and topics of the international year. Does anyone of you want to reply to the comments that were made by other members of the panel? Nobody. Okay, then let me be more direct, yeah, and bring you on the spot. Maybe one aspect that we haven't addressed yet, and it's one of the topics of the international year, yeah, is the one of financing basic sciences. Yeah? Mark, you're a finance guy. What is your take on what and let's limit it to South Africa and Africa. Yeah? How do you see us going forward financing basic sciences? Yeah? Because if we look at the ratio of GDP that South Africa invests in research, yeah, is a little bit smaller than what other countries invest. Yeah? For instance, China, yeah, they invest much more. Yeah. Mark, do you have some spontaneous comment on this?
Yes. So I think when you look at different sectors, there is obviously different magnitudes of investment based on how much each sector. Obviously, you would expect the corporate sector to be able to have much more financial power. But I think the traditional model of developing skills and assigning resources in science has not been sustainable because probably there's a bit of disjointment. I think I mentioned different sectors need to work together. And by working together, it will indirectly solve for where prioritization of resources go to, understanding the challenges science is facing, but also how does the science field evolve as globalization is also evolving. I think you'll find that in the corporate sector, normally funding and resources are assigned based on what must be solved for, and these are some of the things that can drive collaboration. Collaboration. And then the other part is the role of science in actually creating new economies that would actually go back to the science field. Science by itself plays a major role in understanding its role in solving these problems, but also in evolving the methodologies that are being developed through tertiary institutions or even collaboration where possible. It's important that also some of those initiatives are around creating efficiencies so that some funds can be released back into the system. And I think when you look at more advanced worlds, that's how they're almost creating a cycle of funding into the field of science. It's almost a self-funding model. And that makes it a bit sustainable, not just in the shorter term, but also in the long term.
Thank you very much, Mark. That's I think you raised a really fundamental aspect maybe of public-private partnerships for science and research. Yeah? That's probably that's a really nice way of putting it. Since you gave us a comment from the private sector, can I maybe ask Zurab to make a similar comment from the academic sector?
Sorry, Francesco, I was busy replying to Donovan. A comment on what exactly?
On how do you see the financing of basic sciences going forward? Yeah, and probably mathematics is one of the cheaper disciplines.
Yes, it is one of the cheaper disciplines. Nevertheless, even mathematicians need a bit of money. Close human interaction creates a mathematical environment which is difficult to replace, which brings new ideas and so on, and to collaborate you need to visit each other and so on. The computer is definitely needed in computations and so forth. I don't think I am able to make a good suggestion about financing. Perhaps, yeah, it is really a difficult question, but maybe the process for accessing, I mean, there should be some funding allocated for core sciences which do not have immediate applications, right? But then the process of accessing this funding should be very carefully monitored, where judgments are not based on how impressive report you can write, but actually how impressive science you can produce. Because it's a bit easier to write impressive promises on the paper than to actually fulfill those promises. And maybe one shortcoming of modern processes for accessing funding is that a lot of judgment is based on how well the person can compose an application. And even to evaluate mathematicians' contribution is done more based on the numbers associated to the journals in which you publish, such as impact factor, for instance, than the actual content of your mathematical publication. So a bit deeper approach should be taken there to ensure that we channel money in places where it actually is used in a meaningful way. And not to turn this into a numbers game of getting that many citations, that many impact and so on. And eventually it's just a coincidental number that doesn't really guarantee quality. So quality is very important here. And after revisiting and adjusting, learning how to assess quality, then the funding that's available can be distributed across mathematicians. But mathematicians definitely need funding, and especially pure mathematicians cannot prove to you that after 100 years their ideas will be useful. Ada Lovelace that I mentioned earlier would not have been able to provide such a proof because the computer was made only at least 100 years after. So some trust is needed there, but then making use of that trust should be a very careful process. Thanks.
Thank you, Zura. And you know, I made jokingly the comment that mathematics is cheap, yeah, but without infrastructure, yeah, not even mathematics would be able to work these days. And maybe this is the moment to ask Happy, who is in charge of our cyber infrastructure, maybe to make a comment on how he sees the financial aspects of our basic sciences operation.
No, thank you very much, Francesco, for that. And I think one of the things that I would like to add to what my colleagues have already indicated, most of the time, there is always this pressure of saying, show us the results. And in the basic sciences, we cannot always see the benefits immediately. But one thing that we are sure is that once the benefits are realized, they are long lasting. So the only important thing that we can do is to plan for this unintended consequences of supporting basic sciences. And I'm using the word unintended consequences here because you asked me to channel this towards infrastructure. To say we have got the appetite to invest into infrastructure. I think now, if we look in South Africa today, investing in infrastructure like national integrated cyber infrastructure is very important. And we might just be looking at the infrastructure doing the work. And if we forget that there is some basics of the science, underlying principles, scientific formulations that needs to support this infrastructure for its sustainability, then we might be losing the point. Similarly, if we look now, we have got big infrastructure support for astronomy in Zura. And one of the things that we looked at right at the beginning, when we wanted to convince the world that we need to support the square kilometer array, was what will be the benefits for that. And we came up and discussed a lot of things coming from businessman point of view, to say if you put in this amount of money, this is what will come out. And very little was said about what is the sort of drive that will push some of the basic scientific innovation that comes out of there, which cannot be quantified immediately. A simple thing of where we're looking at how many kids, for an example, in the Northern Cape, once they start seeing the telescope, will start being interested in physics or just in the sciences, was never calculated. And I think those are some of the things that we need to look at, to say, with every funding of infrastructure, if we can ensure that not every rand and cents are calculated into what will build that infrastructure, but also bring in an element on what will be the basic sciences that will be driven, and allocate some portion of our funding on that, then we won't get it right. So I would say those are some of the things that we really need to look at and emphasize that they are being attended to. I know we tend to focus our attention on the KPIs of the tangible things, but we should look at this also as one of the areas that we should pay attention to say, what are the basic sciences? Do we just go out there just to publish the gospel of basic sciences and get people interested? I think that will be a winner also. But also in terms of what will be some of the basic sciences ideas that come out of there as part of the research that might ignite some other innovations in the future that can be looked at. And we know we should not really time these things, because it will be difficult, as we said, to get them as timed objectives. Thank you, Francesco.
Thank you. I'm happy for raising some very important issues. Yeah? There is another aspect that we should address, and I think we have one of the specialists here, Anwar, and that is the role of open science and open data in all of this. Would you like to briefly comment on that, and maybe also tell us what the official position of South Africa is in this respect?
Yes, thank you, Francesco. I would like to respond to that, and to, I think, a comment that was made in the chat to solve, I'll first focus on the chat comment. Solve the grand challenges, we need multi and interdisciplinary thinking. And I would just want to agree so much with that statement. What we now find today, especially, is that most of the developments, especially the cutting edge and what is called viral applications, happen between the cracks of the disciplines. So if you combine, for example, remote sensing with climate change, then you get new innovative products that combines those disciplines in a very productive way. And referring to the financial aspect, I would like to mention one word, and that is small and medium enterprises. Well, it's not one word, but that is the generator of competitiveness, of financial competitiveness, is when we can start to reach a critical mass in the small businesses that support our economy. And for them to do that, the basic sciences are key. I would like to show, if I may, Francesco, a picture. It comes from a strategy that we've developed called the big data strategy. I hope you can see this.
Yeah, you can see it. Yeah.
Yeah, and what this picture shows is how it's focused on big data, but I think it's much more generally applicable. And if you look, for example, on the left of that picture, where you see big data strategy, that can be generalized into basic sciences. And we must remember basic sciences would support this big data analytics as it is mentioned there. But what I would like to focus on in this picture are those arrows, how the outputs of what we call basic sciences cascade into the private sector, building areas like developing areas like commerce, industry, cloud, and so on. And we know now today that the government, for example, has put a lot of emphasis on the fourth industrial revolution. Now, if you don't have this basic science pipeline, that would be very difficult to achieve. And then the further arrow shows how all of that developments can cascade into the public sector, and we can address issues that were mentioned before, like health, climate, and energy, and so on. And so I just wanted to show this picture to illustrate how important the basic sciences are for developing the country. I'll stop sharing now and just focus on your question, Francesco, about open science.
Yes, please.
So there has been quite a lot of developments recently, especially at governmental level, focused on the development, firstly, of what they call a policy framework. This was done a few years ago. I think you were involved in that, Francesco. And that resulted in a document with a set of recommendations, policy recommendations. Subsequent to that, a new effort was started this year on the development of what we call an open science cloud, a framework for a South African open science cloud. So this is in progress at the moment, and it's nearing completion. And the outcome of this effort will be for South Africa to develop what we call an open science cloud platform. And I think we need to think about how this outcome, how this output will actually support basic science and the development of basic science in all areas. So this is a very important component in the puzzle. And I think what we should also realize is that there's a chain of achievements that we must have before we can really show the impact of basic sciences. If, for example, Einstein worried about impact then his theory of relativity would probably have been shoved under the carpet. If Dijkstra, with his search algorithms in computer science, if he worried about impact the way we want to see impact, or our funders would like to see impact on a spreadsheet, then those algorithms would probably never have developed. But today, we know that those kinds of basic science outputs, those are the primary drivers of economies, technologies. You mentioned quantum computing. All of those things are important ingredients for us to achieve sustainability, to manage our resources, to address challenges, and so on. So the open science movement globally is one of the primary reasons for having starting this trend, is to involve the citizen, is to involve everyone in the basic sciences. And this global open science platform, which is being, cloud, I should say, which is being developed, the main aim of it is to allow countries to join hands, to work together on global problems. And for that, South Africa must come to the party. One way to do that is to build out our basic sciences. So that's just my comments, Francesco. Thank you very much.
Thank you very much, Anwar, also for addressing the other point that we haven't discussed yet, of science as the conduit to dialogue and consequently also peace efforts. Yeah. And unfortunately, we know that we need lots of those in our global world these days. Yeah. I'm just looking at the time and I see that we have only a couple of minutes left. And maybe we should, before we conclude, allow each of you to make a last statement. Yeah. Let's start now in verse order. Happy, would you like to start with a brief statement just to wrap up the discussion of today?
Thank you very much. And all what I can say is thank for NITheCS for arranging this conversation. And I can just maybe say this should not be the end of the conversations, because we are talking about the international year. So I hope this is not the end of it, and would really like to see
just the beginning.
Yes, no, we really like to see this
before the official. We start before the official launch. Yeah, so we want it to be first.
Thank you for that, Francesco, and let us take that the ultimate goal is to see something really happening for the basic sciences as the efforts towards the end of this year to help us sustain the momentum. Thank you very much.
Thank you, Happy. Mark, would you like to make your final statement?
Yes, so thank you so much. My view is that we need to build on trust in science. Trust is key for the future. And we want to be in a situation where science is the go-to place when we want to have a solution or when we want to have ideas. We need to also build on partnerships, obviously embedded by what we all want to achieve, partnerships between all the sectors, so that the value of science can be felt across in a more aligned way. So that trust is important, maybe even continued driving literacy programs through sessions like this. But trust, especially from the non-science world, is very, very important. Thank you.
Thank you, Mark. Thank you very much. That's a very fundamental aspect. Yeah, Anwar, maybe your final statement now.
Thank you. And yeah, I'd just like to echo what has been said already. Thank you, firstly, Francesco, for allowing us this opportunity, allowing me to speak on this. I think there was some comments also on the chats, and it might have been good for us to perhaps focus on some of those. But I would like to support especially the statement by Mark on us joining hands, the public, private sector, and companies, and the education sector. That is so important for us to build out developments in basic science. And I'd also like to echo what Happy said about this not being an event, but the start of a process for competing and becoming more capable in the basic sciences. So just from my side, thank you, and for allowing us to express our opinions.
Absolute pleasure. And Zura, your final words, and then I will wrap up.
So as much as it is important for experts to speak, I think it is also important for experts to listen to each other. And as an example of this, instead of saying anything further, I would like to invite, if I may, Francesco, with your permission, of course, anyone from the audience who wants to add some remark instead of me about mathematics. And specifically, I see there was a request in the chat by Amorto Goswami. Maybe he would like to, and I will listen instead of saying anything.
He just appeared miraculously on the panel.
Oh, wow, nice.
Amartya, please, just a quick statement, please, because we are running out of time.
Yes, Francesco, can you hear me?
Yes, we can hear you.
Yeah. Okay, if you allow me, I like to extend this word NITheCS, because this NITheCS is the perfect place what we are discussing in the following sense. We are talking about basic science, society, and sustainability. Now, if you looking at this word NITheCS, it says theoretical and computational sciences. Now, if you take this theoretical part, that we can consider as a basic science, and then the computational part, that we can think about how we apply this basic science to the real world, because end of the day, whether it's a quantum computation or it's a computer or a data processing, anything, what we are doing essentially is actually we are computing. And for doing the computation, we actually develop some kind of theory, which is part of this basic science. So the sustainability comes here in the following sense that as we know that better is our computational process, we can actually minimize our time, our resource, and that's in some sense is actually sustainability. So developing proper theory, which is nothing but the basic science, is actually complemented and actually supported by the corresponding computational aspects of the science. So it is absolutely don't need any kind of justifications that why basic science should be supported and should go, because any kind of human civilization's growth, whatever we think today, making our life simple, is based on some kind of development. And the development, if you think from the science point of view, is actually coming some kind of computation on the backside of this machine or whatever we think. And that computation is based on some kind of theoretical science. So I strongly excited and believe that NITheCS is in South Africa. Maybe this is a first platform where we'll get these very nice combinations of this basic science and the society and its applications. So thank you, Francesco, for leading this NITheCS, and it is going to be the landmark place for basic science and society and its sustainability. Thank you.
Thank you, Amartya, for the advert. Thank you very much. So let me wrap up. First of all, I'm very grateful to our panelists. Thank you so much for your time. I know that all of you are very busy persons, so thank you very much for sharing your time with us, and also for sharing your insights. As Happy indicated, this is just the beginning. Yeah. Because we committed to our Academy of Sciences and to the SI to have at least one monthly event dedicated to this international year. And this evening, You saw we didn't have even all the NITheCS disciplines represented. Yeah? So this was just the beginning. So we will definitely have other such panel discussion with the other NITheCS disciplines that we couldn't have this evening. And also, and this is my fault, my apologies, you know, the role of inclusivity and women in science is high on the agenda of International Year. Yeah? And this evening, we didn't have many women on our panel. Yeah? So we will definitely have to organize a panel discussion to address specifically the topic very soon. Yeah? And maybe as a final word, you know, as Amartya mentioned so nicely, NITheCS role is to promote all aspects of basic sciences, yeah? In research, in training, in engagement. And for that reason, every year is year of basic sciences for NITheCS, not just 2022. Yeah. So this we will happily promote the International Year, but we need to make sure that every year is International Year of Basic Sciences for NITheCS, because that is our role. Yeah. So, and on that note, again, thank you very much to all the panelists. We really appreciate your time and your inputs, and thank you very much to the participants for following us. And very shortly, we will announce the next activity in the program to celebrate the International Year of Basic Sciences. Yeah. So, thank you very much, everyone. Have a good evening. And hopefully we will see you very soon on this Zoom channel. Yeah, thank you very much. Have a good evening. Bye-bye.
Bye-bye.